Thanks for coming. We'll be talking about testing salt states. My name is Seth House, and Anderson and Justin Findlay are with me. The three of us are engineers at SaltStack. So the very first thing we got to get out of the way is the scope of this talk. One of the things to keep in mind is this talk is going to get pretty deep into the weeds. We're talking about two new features that are in Salt, but they're still early days. They still require development and code thrown at them to make them fully useful. So they're kind of useful out of the box, but they're not fully realized yet. So we're going to be talking about the history of salt states, and we're going to be talking about the problems that these solve. But keep in mind, this is not like a talk you're going to walk away from and be like, OK, problem solved. I got this from here on out. This is something that we're going to have to be building up over the next year. So as part of that, we're going to do a little live coding. We're going to do some code diving. And so if that is not what you're interested in, now is a good time to duck out and go to your plan B. No feelings hurt at all. All right. Let's talk about the spectrum of testing in Salt as it exists today and has existed pretty much since the very beginning of Salt. Most of this is stuff that's been in Salt for, 3 years, give or take. So maybe 2.5 and some change. So here's kind of the spectrum of what we've got. Before I go into this in a lot of detail, let's talk briefly about what a state is, what a state run is, right? You guys are probably already familiar with the render pipes, right? Salt's renderer system and the render pipe where you put something in Jinja. And you run that through the Jinja interpreter. And whatever that produces, right, a string of some sort. Jinja is a templating language, so it's going to produce a string of some sort. That gets handed off to YAML, right? That's the next step in the render pipe. And they're all separate steps. And so Jinja produces a string, hands that off to YAML. That goes through the YAML parser, and that tries to interpret that string as a data structure, right? That's by using that YAML syntax. So at the end of that, assuming everything's gone well, you've got a data structure. You've got a dictionary. And that dictionary is in the format of high state, hopefully, right? That we call that data format. When you write a YAML file, you're building out a data structure, and we call that data structure the high state data structure. And that is the data structure that's handed off to Salt State Compiler. Salt State Compiler knows how to parse that in a particular way. It takes that high state, it translates it into what we call low state. Really, the big difference between the two is high state is human-friendly. It's easy to read. Package.install the Apache, and you're done. Whereas the low state is a little bit more machine-friendly. It's easier to reason about programmatically. And roughly what it is it's a list. It's an array of dictionaries. And each one of those dictionaries is an interpretation of that high state, which is mapped to a function call. So package.installed, it finds the package module, it finds the installed function inside of that, and it maps all of the arguments you've put in that dictionary to the arguments that function call takes. The way Salt does this is we've got a utility function called format call that we use all over the place in Salt. It is one of the more common ones we call. So find that in the source if you've got a bored hour one day. So its job is to take a dictionary, take a function, inspect the function, and then try and compare the two, right? I've got this dictionary. I'm going to try and map the keys in this dictionary to the arguments that this function takes. So Salt State Compiler does that, right? And produces that low state, and it starts. It does some sanity checks at the beginning, just to make sure that looks like a valid state, to make sure that there's no recursive requisites, to make sure that there's no duplicate IDs, that sort of thing, right? The high state data structure, as you guys know, is a dictionary, right? So we've got to have unique keys. That's why Salt will complain at you if you have a duplicate key there. So it does some sanity checks, converts it into low state, and then starts executing on it. So as I mentioned, it's an array. It's ordered, right? We sort that array by various things. You can put the order directive, right, in your state. It's not commonly done, but you can definitely specify a manual ordering. Salt will keep track of what order it finds certain states in the file when it's going through the YAML parsing step. And so it'll keep that counter, and so it'll just start executing on that list, one after the other. And so each function call is completely in isolation. And so each one doesn't know about the previous or next. So it runs package.installed, and that produces a return. You guys are familiar with this return from the high state output. It's the result, the changes, the comment, and the name field, right? And so it takes that return dictionary and it puts it into what we call the running dictionary. The running dictionary is what you guys are familiar with when you run a high state or a state.sls. That is what you get back at the console, right? This ran, it either succeeded or failed, here were the changes or not that it affected on the system. So that's the whole process, right? So debugging salt states can be trying. And so let's talk about the first kind of bit of ammunition we have to do that. So it's the show high state and show SLS. What these commands do, I'll pull it up while I'm talking. What these commands do is I've got a simple salt state here. It's not doing anything. It's just a file.managed, putting a string into a file on disk. Not a lot to say about that. So let's see. Let's do show SLS. Okay, I'm going to run it first normally, and then I'll re-output it in JSON format. So this should be familiar to everybody. Okay. What this this data structure is the high state data structure. It's got some keys in it that Salt puts there for you, but roughly it's what we typed in verbatim, right? File.managed. Very slight format differences, but then you can see we've got the order key. Salt keeps track of what environment it came from and what SLS file it came from for various reasons. But let's look at it in JSON format, right? We're going to be talking a lot about data structures this talk, and Salt's state system is all about data structures, both in and out, and so we'll reason about them from that layer since we're kind of getting into the weeds here. So there we go. So JSON. What this show SLS does, or show high state does, is it takes what you've typed in, it runs it through the very first few steps that we talked about. So it runs it through YAML, or Jinja, excuse me, it runs it through YAML. And then it runs it through Salt State Compiler and does those pre-checks that we talked about, to a degree. It does some of the checks. And then it outputs the result. So it doesn't get to the part where it's executing any of the state functions, and it doesn't get all of the checks that you'll see in a full state run. But it's useful because if we get this far, right? If we get this far, we know there were no Jinja syntax errors. We know there were no YAML syntax errors, and we know that we're probably okay with Salt high state syntax errors. So this is a good way to just do a quick sanity check for syntax. So show SLS and show high state. Quick raise of hands. I'm curious. How many people routinely run show SLS or show high state? Ah, perfect. About half the room, a little more. So useful for those syntax errors. For those of you who are not familiar with doing this, get in the habit. It's a nice thing to do. And when Salt spits you out an error with this render pipe syntax, the thing I like about the syntax is it very directly tells you what's going on under the scenes, right? Do this step. Take the result of this step, pipe it into the next step, right? Very Unixy. So when you're looking for errors in these steps, look to see if that error came from Jinja, or came from YAML, or came from Salt. Since there are those three steps involved, you have to see where that error came from. If you're using a non-standard renderer, of course, which is an easy thing to do, using the shebang syntax, right? If I wanted to write this using Python instead of YAML, then I would make a run function that returns a dictionary, right? Something like that. So it's easy to switch between renderers, and whenever you do that and you run into errors, you have to keep in mind where the error came from, depending on what renderer you're running it through. All right. So that'll show you syntax errors. Next up is test equals true, right? Test equals true is useful for debugging ordering. This is not a well-known trick, but it's very useful. If you've got a large state tree and you've got a lot of, you're making heavy use of formulas that you're pulling out of the formulas GitHub organization, or you've got just a very large state tree in your organization, and there's a lot of includes, there's a lot of requisites, that sort of thing. It gets a little tough to visualize the order that your states are going to run in, right? Salt from the very beginning was written to be declarative. It was written to have the same ordering on every single execution. That'll never change, right? Once you've written your state, it'll always always execute in the same order. But with requisites, since it's declarative, the requisite can change the order of that execution, and so you have to visualize those requisites in your head as you're kind of reading through the state, because requisites are evaluated at runtime. So when we do the show SLS or the show high state, requisites haven't entered the picture. So we talked about the low state, right, where Salt is going through that ordered list, that ordered array, executing one state after another. So we get to package.install, right, Apache. So it installs Apache. Then we get to service.running, and service.running has a requisite, so that the service doesn't get started until the package is actually installed, right? So Salt stops at that point. It says, I can see I've got a requisite here. Has this requisite been satisfied already? And so it looks up in the running dictionary the key for that requisite. That's how that works. So it consults the running dictionary saying, do I have an entry? Do I have a return value for this package.installed already? In this particular example, we do. And so that requisite is satisfied. So it executes state.running and continues on. If not, right, if it hadn't been run yet, Salt will pause execution. It'll find package.installed in that state tree, execute it, put that in the running dictionary, and then resume execution where it left off. So that's how those requisites are resolved. And requisites are evaluated at runtime. Now this makes it hard to reason about the order that Salt states are going to run in with very large state trees for this reason. But it also gives us a great deal of power for things like prereq. If you're not familiar with prereq, it's one of our very complicated requisites that is terse. And just a couple of lines of code, you can do some really complicated things like it lets you do something optionally. So if you've got a prereq, you can do things like, I want to shut Apache down. I want to drain Apache out of users before I update my web application. But I don't want to stop Apache if my web application is not going to update. I need to know that in advance. So prereq lets you do that. It lets you check to see if there will be an update when you update your application, your web application. If so, then it drains Apache. It updates the web application, and then you can bring Apache back up. And you can do this with the prereq requisite in a few lines of code, but this is something you kind of have to do at runtime. So that's why requisites are evaluated at runtime. So back to test equals true, to debug ordering. The running dictionary is the order that things ran in. And so this is a nice way to debug exactly that. Let me Salt Apache. So I've got a simple Apache state here, right? Install the package, start the service. I'm going to run it. I'm on my development machine here. I'm on a Mac, so it's not going to go too far, but it'll show us what we need to see. So I'm going to do state.sls, Apache. I'm going to do it in test equals true mode. And I'll do it without piping it to JSON first so that it looks familiar. So this is going to fail. We're going to see a bunch of red, but that's not what we're interested in. When you're debugging Salt states, since there's a lot of layers involved, it's an important thing to debug one thing at a time, right? What are you debugging right now? If I'm debugging ordering, I don't care that these failed necessarily. I just care what order they ran in. And the running dictionary shows you the definitive order that they did run in, because we actually executed these state functions. They did run in this order. You can see the very first thing that happened is we tried to install Apache. The very next thing is we tried to start Apache, right? So if I were to, say, do something like this and move it, right? So as you guys know, Salt executes in source order by default. So this is going to not do the thing that we want. So let's toss in a requisite. Install Apache, right? Now it will do the thing that we want, but it's still out of order. So let's check it. And you can see the running dictionary still tells us the order that it did run in. So that's why test equals true is useful for debugging. Salt keeps track of this as it goes. If you look at the actual JSON, you can see that the way Salt keeps track of it is it puts in a counter as it puts everything into the running dictionary. And so there it is, run num 0. So that's how Salt keeps track. Okay. So useful for debugging ordering, but it's a little heavy, right? We'll circle back to that. Okay, finally, you've written out your state tree, right? It's a good idea when debugging Salt states to do so incrementally. Don't write 500 lines of SLS files and then kick it off in dry run mode and see what happens. You'll have a long night ahead of you. Do it individually, right? Make small SLS files that do one thing and do it well, right? Follow the formula conventions. There's some best practices in the formula docs which go over this in detail. Debug that incrementally, and so you can, what that lets you do is that lets you run individual SLS files outside of the context of, say, like a full high state run, and you can just debug that one thing, and then the only thing you have to debug when you piece everything together into a full high state run is the ordering of the whole thing. You already know that each one state, does the correct thing on its own. Now you just need to make sure that they run in the right order. Okay, so that brings us to test equals true again. But this time, we're not interested in ordering. We've already got that resolved. We're interested that Salt states actually did the thing that we wanted them to. So, go out to the system, check to make sure that, that everything went as expected. So let's talk about briefly how Salt state modules do that, right? Most Salt state modules, with just a few exceptions, adhere to the following contract. This is detailed, by the way, if we go to the main Salt docs. You go to the index page. Should have pulled this up in advance with Wi-Fi being what it is. So if you go to the state documentation, apologies, I've got a rogue extension here that sometimes likes to eat up my CPU. Sheesh, like a lot. So I'll keep talking while we're waiting for that. Let's see, in the state docs, there's a document called Writing Salt States. And it talks about the ideal for a state module. Ideally, a state module should do as little as possible. Ideally, an execution module should do all of the work, or a bunch of execution modules, right? So let's go over the package.installed state module. The very first thing it needs to do is to check, to see, do a pre-check. Does anything on the system need to change, yes or no? And it finds that out by calling an execution module, in this case, package.listPackages. It lists all of the packages on the system, and if it's already in that list, then there's nothing to do, right? We don't need to install Apache. It's already installed. It's already in the list of installed packages. Problem solved. So if you come to the main Salt page, you jump down to Configuration Management, Writing Salt States, right here in the front. So if you jump to that, then there's an example of an ideal Salt state here at the bottom of the page. So, well worth pulling up if you ever have to do this. So the state module does the pre-check. Does anything need to change? And it calls out to an execution module to figure that out, right? Say something does need to change. Apache is not installed. To install Apache, it's going to call out to an execution module to actually install Apache. In this case, it's going to call package.install, present tense, the execution module to get that installed. But first, we've got to check to make sure that we're not in test equals true mode, right? So it's really this simple. It looks to see if we're running in test equals true mode, which is here. If we are running in test equals true mode, we want to tell the user what's going to change. Okay. Apache is going to be installed. And then we're just going to short circuit. So we're just going to call return and output this dictionary that you guys are already familiar with result and changes. Okay? So most state modules adhere to this contract. And then finally, if we're not in test equals true mode, actually call the execution module, make the change, and we want to tell the user what did change. Okay? So this is pretty useful information. But it's the way it's been structured, pretty much since the beginning is it's useful to humans, right? It's useful to you guys reading this. It's useful to you guys pulling this up and Splunk 6 months down the road to see what did happen 6 months ago, right? you have to read it. It's in a dictionary, it's a data structure, but a lot of these state returns are not richly formatted. So you read it, you see what happens. In the case of file.managed, this module has gone a little back and forth on this, but for most of Salt's history, the actual diff, right, when you run file.managed in dry run mode, and it's going to show you the diff of what will change, how that file will change, it puts that diff in the comment field, not in the changes field. Because the contract in test equals true mode is the changes dictionary should be empty, right? We didn't actually change the system, so don't populate changes. So it puts it in the comment field. So it's useful to you, humans, but it's not useful programmatically. So a little less than ideal, but circle back to that as well. So that's kind of the scope of things. Test equals true is useful for a couple of things, right? Before you run the full state run, show me what's going to change. And it's useful for after you've run that state run. Tell me if my system is still in compliance, right? So tell me it still matches this SLS file that I've already put together. So if you run it in test equals true mode, you get nothing back, you're good. And Salt's pre-checks are pretty lightweight, right? Most all of those pre-checks are designed to be fast, right? When we call package.list packages to see what packages have been installed on the system, we do that in the fastest way possible. We call out to RPM-Q on Red Hat systems. That's not true anymore. We're calling, on Debian, we're calling dpackage. On Windows systems, we're consulting the actual registry. So we get that list really fast. So we can do that pre-check really fast, and that's one of the beauties of Salt state runs, right? If you take a shell script, you convert it into a Salt state, it's going to run faster than the shell script because we've got all of these pre-checks built in, unless, of course, you've gone to that trouble of building that into your shell script. So, it's a common practice in my experience to do a dry run on your infrastructure just as kind of a sanity check. Is it still in the state I expect? Did, what's his face who, the CTO's nephew that happens to have the root password to that box, did he log in over the weekend kind of thing? However it is. Some of our larger customers do this on an automated fashion, right? They put the dry run in a schedule, they toss it up to Splunk, and they grab and they look at that over time, right? Did anything unexpected happen over the weekend kind of thing? So useful programmatically. All right, so that's where we've been. Any questions about that before we move on? So we've got two additions that we're going to be talking about for the rest of the session. Mock runs and predictive changes. So a mock run, very briefly, is like a dry run. The thing that a mock run is going to tell us is it's going to let us debug ordering. In its current state, it lets us debug ordering in the same way that we were using test equals true to debug ordering. This lets us do that a little bit faster, and in the future, a little bit more granularly. We'll talk about that. And then the next thing is predictive changes. So as we talked about, the changes field is only populated if the system actually changed. And that's programmatically useful, but sometimes we want that data programmatically available in a dry run, right? Is the system going to change? How much of the system is going to change? And so that's where predictive changes comes in. This is going to be a place, it is a place, it's in there now, and we've got to add this to a bunch of state modules, but this is a formal place to now start piling in programmatically useful data so you can pull it into tools and drill down on it over time. So, with that said, let's talk about mock state runs in detail.
So now is the part of the presentation where I get to say my bit. It's easy to feel like a kid next to Seth. So really the advantage to mock state runs or state mocking is, so it's very much like running test equals true. Instead you say, you run state.apply, state.sls, whatever. Instead of running test equals true, you run mock equals true. And so what that does is, so I like to think of how the state compiler works as a stack of different steps. Each step is the data is processed incrementally. You start with your Jinja and YAML for most people typically, or as Seth talked about, you can have different renderers. So that's the data that gets inserted into the state compiler. So what mock equals true does, also, as Seth mentioned, requisites necessarily being as a complex kind of thing are evaluated at runtime. So what mock equals true does is it gives us an exit point out of the state compiler at that point after the requisites are processed, but before execution is handed off to the state module functions. So that gives us an advantage to quickly look through the running dictionary without any changes made, so you can see what the ordering looks like.
I'll pull that up in Salt's actual state compiler. If you're ever interested in diving in here, it's salt state.py, and it's large and complex. But
Right.
this is that function that Justin's talking about, mock ret. So this mocks the return, and you can see it's returning all of the normal fields that you're already familiar with.
So one thing that hasn't been determined yet with this is how we're going to, we'd like to add some functionality in here in order to allow the user to tell the state compiler how that particular state is going to be evaluated. Like, is it going to succeed or fail? So in a normal state run, you have a simple graph. You just have a list of states. But for example, if you have an on-fail requisite or something like that, you could have a branch point in your state tree. So the idea being, if I have a complex set of SLS files sourced from a not necessarily determinate set of file roots and whatever, but I want to see explicitly what's going to happen, and then regression test this in a safe way, then we can mock in, okay, let's say this does fail and we go to the on-fail requisite. Let's make sure what is going to happen is what we want to happen.
Well said. So let's look at what an example of that might be useful for. Let's say we want to put the config in place. So for that, we're going to do a Apache config, file.managed. That's the httpd, conf.d, apache.conf, something like that, right? Pulling this out of Salt somewhere, of course, Apache, conf, httpd.conf.template, right? So this is the template we have on the Salt master, putting that down on the minion. And whenever this file is updated, of course, we want to Apache config, there we go. We want to restart the Apache service, or as you're more likely to have this. Start Apache. So you're likely to have something like this. Whenever the config file changes, bump the Apache service so that it picks up that change, right? So here we've got something like a decision tree in our state tree, right? You can see you can think of requisites as branching logic. The more complex they get with on changes, with on fail, with prereq, the more complex your state tree is going to get. And you can think of it as a tree. There's a nice community project which Salt, oops, that's not going to do it. There's a nice community project that I've wanted to get into to Salt Core for a while. I should sit down and make it happen, but it's called Salt State Graph. It takes the high state structure, it runs it through GraphViz, and it shows you I used to have a screenshot. Oh, there we go. Shows it as a tree, right? It is a tree. It's useful to see it as a tree. This is one of the things that's also on our roadmap for the enterprise product. Right? We've got all of this rich data because a state run is a data structure, so why not graph it as a tree? And so it's useful to be able to model what's going to happen the more complex this tree gets, right? Show me how my state run will behave if this state here, this Apache config state, does have changes. Show me what happens if it doesn't have changes. And so that's where mock runs are going to really kind of come into their own. Right now, as it exists in Salt, you saw I run it at the CLI earlier while Justin was talking, you can see the ordering information exactly as you can with kicking out a dry run, but now you don't have to kick off a dry run. It's a lot faster. It's calling a function that returns a dictionary, and that's it, right? But say we can inform that function what we want it to return, rather than just hard-coding the return value. So that's the idea behind these scripts. So the syntax for this is still very much up in the air. We've gone a couple of ways, right? Maybe a script, maybe a mock script should be a standalone file. Maybe it should be a module. Or maybe we can just put it in line in the other state itself. So all of that's pretty up in the air. So maybe we've got something like lock in. And for this, we want it to return result is true, right? So we want the state to succeed, and we want changes to be non-empty. So a dictionary, something like did change true, something, whatever, right? So this kind of thing, whatever the syntax ends up looking like, would allow us to say, kick off a mock run and model this decision tree, this leg in the decision tree. Any questions about mock? If anybody wants to explore uses for it or syntaxes for it, I'd love to chat afterward.
Is that staying in the file itself, or is that going to be moved out of parallel?
Could go either way, whatever's most comfortable. If we went with something like this, it's nice and terse. We pretty much just care about those 2 data points, resultant changes. So that doesn't bother me particularly, but I can also see the value in having a separate mock script. Yeah, the state module. Test is actually calling the state module. So when we've got the high state to the low state, which is that array of dictionary objects, and the salt state compiler will start going through executing the actual state functions. In dry run mode, the state function is run, and the state function has the check, the are we running in dry run mode check within it, embedded within it. Usually it's just an if statement looking to see if test is an ops. Ops is salt's config, global config. So, the state function itself is run, and those pre-checks are fast, like we talked about, but you're still doing an awful lot of work. Versus mock, instead of running that state function, it runs that function we were just looking at in the state compiler, which just returns a dictionary. So, it's that fast.
Can you show that in a project again?
Salt state graph. It's a good project. We need it in core. We need a state.graph. All right. Yes?
Is this going to get first-class support in the orchestrate runner?
It is in the orchestrate runner. One of the beauties of the, a great question, thank you for asking it. One of the beauties of orchestrate, I was sort of a late bloomer on appreciating orchestrate for what it is, but orchestrate uses the salt state system, period. Doesn't matter if it's running on a minion or the master. And that's one of my favorite things about orchestrate. It seems kind of counterintuitive that you can call all of those same state functions on a master, but since it's running on a master, you now have access to all of the same things that a master can do, including calling out to minions, calling out to salt key, all of those normal things. So orchestrate is a state run. It's just a master side state run, and so mock is already available.
So could I clarify the question? Does it have support for order checks of the states run within a given state.ls or state.xt?
It does, yeah. Orchestrate has all of the same requisite semantics.
All right, because it's sometimes when dealing with orchestrate, we're only getting the actual salt mod executions, and we're seeing that those are test true. Yes, that indeed would execute, but I'm not seeing necessarily all the subs.
Maybe I didn't understand your question. So when orchestrate runs, and say you do send an execution down to a minion to kick off a state run on the minion, that state run on the minion is separate from the state run on the master, right? The state run on the master is the orchestrate run. It sent the execution down the same way you would at the CLI. the minion did its thing, and when the minion returns that data, orchestrate will pick it up, but it's not an embedded kind of state run. It's just, this was the return that we got. Good question. Any other questions about mock? Yeah, that's a great question. So we've thought a lot about, sorry, the question was, can we use the mock to, rephrase slightly, can we use mock to check the parameters that the function actually takes to make sure those parameters are correct? The short answer is mock isn't quite useful for that. There's another thing that we absolutely need in place because that's a big thing for programmatic validation of a state run. The reason mock makes it a little difficult, or even salt modules make that a little difficult, is what we need to be able to do that is we can already inspect the function. So we can, for any given state function, we can see what arguments it takes. But what we can't see with the inspect module is what we're doing with those arguments in the function body. So for example, oftentimes in salt, we'll take an argument that takes a string, or it takes an array of strings. And we can't inspect that using the normal Python semantics. And so the way we need to solve this is via the documentation system. So the documentation system is structured. And so if we put that information in a structured format in the doc strings, so this parameter takes these one of two of these types, now we can extract that programmatically. We can pull that into things like pre-checks, that sort of thing, and say, we see you're trying to call package.installed, but you're calling pkg, the argument pkg, and we don't have that argument, but we do have a pkgs. Maybe that's what you meant, that kind of thing. And we absolutely need that. That's something that's been a long-standing kind of headache, pet peeve of mine, and it'll be very useful for us in the enterprise product as you're typing out things to be able to programmatically know that. So that's on our short-term roadmap. Mock questions? It is available as of 2015.8. So if you jump to the high state docs, you can see the mock option, a little description of it. 8.4. Thank you. We're running short on time, so let's talk about predictive changes. Sorry, here we go.
Okay, so go to the next slide, please. Thank you. Seth kind of already glossed over or talked about the things I wanted to talk about as far as actual versus probable changes and structuring of data. So I just want to talk about how this compares to something like Test Kitchen and Kitchen Salt for a minute, and then I'll let Seth show how to actually add a module or add predictive changes to a module. So Test Kitchen and Kitchen Salt I'm very ignorant of as of until about 2 weeks ago. Yo. Oh yeah, my bad. How's that? Is that better? Yeah. Okay. So again, like I said, Test Kitchen and Kitchen Salt I just used for the first time a couple weeks ago. So if you know more about it than I do, which a lot of people in here probably do, just correct me. So while Test Kitchen and Kitchen Salt allow you to test your chef runs or your state runs with Kitchen Salt, predictive changes will essentially allow you to, or make it so you don't have to use a third-party tool like Kitchen Salt. So all of that functionality will be built into the state runs. So like Seth mentioned earlier, the predictive changes dictionary will fill out the entire time, from the start of the state run to the end of the state run, whether you do test equals true or not. So ideally, the predictive changes and the changes dictionary should be the same at the end of a successful state run. However, if you do run a test equals true, the changes dictionary generally will not get filled out, but the predictive changes will, so you can see, like Seth was mentioning earlier, you can make for debug ordering and stuff like that, you can see the changes that are actually going to happen or what Salt thinks will actually happen in the state run. Does that make sense so far?
I'll pull it up while you're talking. So we pulled this up briefly. This is file.managed. We're just putting a text file on the other file system. So I'm going to run that. There we go. And I'm going to output this in JSON. So we have not yet added predictive changes, the field, to our high state outputter.
Right, and I forgot to mention that. So it's only visible through the JSON outputter right now.
Oops, I actually ran that. No, I did a
Should
show
fill it out
SLS.
either way.
There we go. Now I'll actually run it.
Yeah. So there should be 2 dictionaries here. There's the changes dictionary, which shows there's a new file, and then there's also the predictive changes, which also shows the new file and then the path that that file was created in. So that's essentially how it'll be, but if you run, was that a test equals true or an actual test?
That was an
run?
actual one. Let's do
so
it again.
A test equals true should not fill out the changes dictionary, so you'll see that the predictive changes will be filled out, but the changes will not. And while he's doing this currently,
Oops, that was supposed to be in test equal true mode. I'll do it again.
currently only the file state has this fully implemented and no other states have it. So it's something that's very, very new and very, very rough. And some states will fill out the changes dictionary. I like this one does. Is this the file.managed?
Yeah, file.managed has gone back and forth on this. Sorry for the bad example. Most states don't have this. I ran afoul of this a while back, and I actually added this, a non-empty changes dictionary, back into this, which broke a bunch of people's installs. That was my bad. So we pulled it back out, and it looks like somebody's added it back. So in any case, the changes dictionary should be empty if the system didn't change. So file.managed is an outlier at the moment.
Right, so any other state run in file, or any of the file states will have that or the changes dictionary empty on a test run, except for file.managed. But provided that's empty, you can still see what you think is going to happen or what Salt thinks is going to happen. You can compare that to if that is what you actually want to happen or if that's, incorrect, and you can adjust your state accordingly. So do you want to show how to add that, or do we not have time?
I don't think we have time to add it to a state module. Let me, I rambled a little bit too much.
You're good.
So since we don't have time to dive into code, let me just talk about the kinds of things that predictive changes should be useful for. So predictive changes is our best guess about how we're going to change a system. So there's some kinds of changes you can make to a system that you don't know ahead of time, ahead of making those changes. But oftentimes we can make pretty good guesses. So in the case of file.managed, it's super straightforward. We can diff a file when we change it or when we don't change it, and put that into the predictive changes output here. So that's pretty straightforward. But how about adding a user to a system? Less straightforward, right? Say we've written a state to add a user to a system. The user's going to have this UMask, this home directory, this default shell, that sort of thing. When we run that, that's obviously going to do all of the things that we've asked it to, but sometimes it'll do other things, right? Sometimes it'll pick up other values from the system. Say we don't specify in our state the default UMask for the user. The user's still going to get one. We don't know what it is ahead of time without doing a bunch of checking before. But the stage had collapsed. So yeah, so we don't know what that change is going to be beforehand. We can do an awful lot of checking, but maybe that's not the most useful thing to spend a lot of time checking in the context of just adding a user. So that's something that p-changes and changes are going to differ on. So p-changes is going to show us, when this state actually runs, we're going to put this user in place with this home directory, and we know that much. And then when it actually runs, we're going to show that in the changes dictionary, obviously, but maybe we can show other stuff too. Right? Maybe we can show what default UMask the user picked up and any other interesting information. So the goal, the philosophy behind this addition is programmatic usefulness. It's a data structure. Make it useful in that context. Pull something into Splunk so that you can drill down on the data over time. We've got a customer that wants to use, they're currently using dry runs in roughly this capacity, and they want to make use of predictive changes in this capacity, but more so, they want to see what their drift, their infrastructure drift is over time. Over the last 6 months, show me how much the following key things on my infrastructure have changed, config files or whatever. Or just show me how much drift my infrastructure as a whole has had over the last 6 months. And with predictive changes, we can have that same programmatic information available in a dry run as well. So kick off a dry run, show me if anything is going to change, and now I can see that in Splunk, and I can drill down on that data since it's available in that data structure. So this is kind of a call to arms. For any of you guys who are inclined, right, you want this functionality in a particular state module. Right now, as mentioned, we've only got it in the file functions in the file module, the file state module. We've got it in most of those. So if this is important to you, please pull up the code and add it. It's a simple thing, right? Anything that is useful to you programmatically in a dry run or in a real run, add it to the predictive changes dictionary. And we're going to start pushing this a bit. So over the next year, we want to fully flesh this out. So we'll be adding docs, we'll be asking pull requests to get it added, that sort of thing. And then of course, we've got this huge library of state functions that we've got to go back through and start adding this functionality to. In the pre-check, in a state function, like we talked about, oftentimes you do these checks already, and you just don't output them in the result because that's not the purpose of the thing that you're adding, right? It doesn't need to be all that verbose. You just need to say, well, I did this one thing. But with predictive changes, it really allows you to add all of the useful bits of information that you might want to see. So we'll also be adding this to the high state outputter. It'll probably be config-gated because it could be a bit noisy, so show p changes, that sort of thing. So call to arms. If this is something you care about, please dive in. It should be pretty straightforward to add. Look at the module that you're working with. Look at what it's already doing for the pre-checks, and just see if you can grab some of the results of those pre-checks and toss it into that dictionary and call it a day. So, any questions about predictive changes? Just a tad over time. It will show up, but it won't be used to make the requisite determination. The question was, are we going to make use of them in the requisite checks correct me if I'm wrong, to inform the requisites direction? That'll still be changes. So that one thing we could do, now that you mention it, is one of the things that none of the configuration management tools do, which is a hard change, is follow a requisite chain and tell me what's going to happen at a midpoint in that chain. And this is a hard problem to solve. So right, if Apache is not yet installed and you're doing a dry run of service.running, well, the service init script is not in place. And so there's nothing you can do to check that without having a lot of Apache-specific information. But p-changes could open the door to something like that. So we expect Apache to be installed, and then it's an interesting idea. Thanks for mentioning it. Other questions?
About the changes in the test run, when you run, let's say you have a prerequisite, a prereq type, a prerequisite for that Apache, and you have a config to change, and you want to start Apache before that config is changed. So you put prereq in Apache instead of start.
Mm-hmm. Right. The question rephrased is in prereq, what does it key off of to know that state's going to produce changes? And back in the day, I think I would have answered the changes dictionary, but I don't think that's true. I think it keys off of result if result is not none. I think it keys off of that, but don't quote me. So we are over time. So thank you for coming. We're available for questions.